Hi, in this video we are going to see about yet another disk scheduling algorithm called C-scan scheduling algorithm. So C-scan is nothing but circular scan scheduling algorithm. It is the variant of the scan algorithm which we have seen in the previous video. So this C-scan algorithm, it is specially designed to provide more uniform wait time. So the C-scan moves the head from one end of the disk to the other end, servicing the request along the way. When the head reaches the other end, it immediately returns to the beginning of the disk, and then without servicing any request on the return trip. Okay, so this algorithm, this C-scan algorithm, is also called as circular elevator algorithm. Okay, so your scan algorithm is called as the elevator algorithm. Your C-scan algorithm is called as circular elevator algorithm. Okay, so here in this case, what it does is like your head will be in some position. So for example, here it is in 53. What it will do is, first it keeps on moving and servicing all the requests in that particular way, and it services everything. Once it reaches that end, what it will do is, it will just move to the beginning of the disk. Once it reaches the end, it moves to the beginning of the disk. When it is moving from this end to the beginning, it won't service any request that is coming its way. Okay, so once it reaches the beginning of the disk, then it continues to service the request. Okay, so we will see how C-scan algorithm works with an example. So here, if we see in this example, I have a disk that contains 200 tracks, that is from 0 to 199. I have a disk queue request, and then my current head position is at 53. Okay, so I'm drawing it from 0 to 199. That means I have 200 tracks, and my current head position is at 53. Okay, so it is going to move to the larger side end. Okay, it is going to move to my larger value. Okay, it is going to move to my larger value. So from 53 it moves to 65. From 65 it is moving to 67. From 67 it is moving to 98, and from 98 to 122, and from 122 to 124, and then from 124 it is moving to 183. Okay, once it reaches 183, it won't stop there. Okay, so this has to reach, your head position has to reach the end. Okay, the head position has to reach the end, that is the extreme end, that is my 200 track, right? So from 183 it is moving to 199. Now my head is at the end. Once it reaches the end, it is going to immediately go to the beginning of the disk. So it is reaching the end, and once it reaches the end, it is immediately going to the beginning of my disk, that is 0, right? So once it reaches 0, from there whichever request is available, it is going to service them. Okay, from 0 my request 14 will be serviced, and my request 37 will be serviced. Okay, so this is the diagram of that particular question. Okay, so once this is done, my main aim is to find out the total head movement once again. Okay, so here also you can use the previous way of calculating, or else the shortcut way is this, right? So first, from 53 it is moving to that end, that is 199. So 199 minus 53 plus, from 199 it is once again moving to the beginning. Okay, so 199 minus 0 plus, from 0 it is moving until 37. So 37 minus 0. So just subtract everything, you will be having 382. Okay, so if you do it in this shortcut way, or if you do it in the way which I have told you in FCFS, both will give you the same result. Okay, so here in this case the total head movement is 382 cylinders. Okay, so this is how your C-scan scheduling works. If you have any doubts, you can just comment on it. Thank you.